Before we start with continuous study unit 4, you guys will probably in the next week or so get the feedback from assignment 1. There will be official feedback from the lecturer on that, and then we can go through that, because you will also send us some of the questions that was asked in all the different types of assignments in assignment 1. So probably next Saturday will be a recap of your first assignment. So let's work towards that. If we don't get feedback yet, we'll just do it the week after. So let's continue with study unit 4. Basically, we're starting off with probability, and we look at just the normal probability. Study unit 5. Yes, there is a question before we start. You can ask.
Okay, sorry. Since we will talk about the assignment next week, I think it's best to ask the question next week because I'm a bit confused regarding a calculation. I think I did ask on the group, but it's fine. There's a calculation that I don't understand.
Yeah, so yeah, I think it's best that we do it next week.
Yeah.
Yeah, because when we have, if there is 2 or 3 types of that question, then we have everything together and we can go through in detail, if that is fine with you.
Oh, no problem.
Okay. Okay, cool. So let's then continue with this. And I think what is important about this study unit is that it's more the concept of probability that one needs to understand, because study unit 5 will do more probability in binomial, Poisson, and discrete, and then we go into the normal distribution and others. So the important thing about study unit 4 nearly is to grasp the concept of probability. So we just started last time on a few of these. So I just want to continue. There's only 1 or 2 more left, and then we can actually start with study unit 5 today as well. I think last year your assignment 2 was based on study unit 4 and 5, if I'm correct. And you will also see the lecturer sent out um, details about when your second assignment will be open. So it's not opened yet. So yeah, so I think it's in a week or in a week's time, something that it will open. Okay, so let's look at this question and see what is in here and what they give us, so that we can answer it. So they give us the one probability of PA, they give us the second probability of PB. Um, then what you will normally get is that they will ask something about mutually exclusive, they will ask something about independent. It might be that they ask one of the rules where it is a conditional probability, so that it is probability of A given B. and it might be that they are somewhere that you need to work out the or and the complement. So that's nearly the things that they would ask in a question like this. So let's look at the questions, and we need to identify which one is incorrect again. If events A and B are mutually exclusive, then A or B is equal to 0.8. Okay, so let's just write that out. So A or B, the normal formula for that is, and again, you guys don't need to study all these formulas. It is on the page that I have shared. So, and remember, stats is open book, so I just do that as an and. Okay, so probability of A or B is equal to probability of A plus probability of B minus the and. So we know nearly if something is mutually exclusive, that and will be equal to 0. So let's see, probability of A is 0.5, probability of B is 0.3. So for that to be mutually exclusive, the probability needs to be 0.8. If events A and B are mutually exclusive, then A or B will be 0.8, which is correct. Okay, because the and in this instance needs to be 0, and it is. So we're happy with that. Okay, so let's look at the next one. If events A and B are independent, then A or B also equal to 0.9. Okay, so what they're asking us here is nearly if we know the difference between what is independent and what is mutually exclusive. So your independent one, and let's just make it, when you go through this again, we remember which one is which. So your independent calculation will be exactly or formula will be exactly the same. Let's be A, and I think what this also now helps is for us to nearly get through all the information and nearly capture it that in one question. Okay, so if we have that, your rule of independence will say, okay, but you still add the first one, add the second one, but your and, for it to be independent, needs to be the one times the other one. So your and will be the 0.3 times 0.5. So let's just, for independent, I just want to add this here. Will be the PA times the PB. Okay, so that's your rule for independent, and then you can see that this is 0.8 again, but the minus 1 is, let's get a calculator. 0.5 times 0.3 is 0.15. So this would actually have been 0.65. Okay, so that means that question about the independent one is wrong, because it should have said the answer is actually 0.65. So basically with between option 1 and 2, they tested if you know what's the difference between mutually exclusive and and independent. Okay. So but let's check for other ones as well. So if events A and B are mutually exclusive, then A given B is equal to 0. So again, let's see if we write that out. A given B, I'm just going to write that as equal to, so that I don't need to write out the whole formula, is basically the probability of A and B divided the probability of B. Okay, so if they say something is mutually exclusive, we know the AND is equal to 0. So 0 divided by 0.3 will give us 0. Okay, so when the two events are mutually exclusive, you can nearly always say that the probability of A given B will be equal to 0. Okay, so in option 3, they test your knowledge about mutually exclusive and then your conditional probability. So again, they will nearly test it with independence as well. So let's again just write it shorthand. I'm not so probability of A and B. And remember, we have nearly worked that out already as 0.15. Don't need to work it out again. Divided by probability of B, which is 0.3. So that will give us 0.5. Okay, so out of this, you can nearly see if something is independent, you can automatically say that if it is independent, you can say A given B is going to be the probability of A. So check here. We've seen it's independent. We've worked out the AND. We know the probability of B. We've divided. We get 0.5. And that answer is the probability of A. So that you also see in the notes I have made a note of that. So if two things are independent, the conditional rule becomes very, very easy nearly. So if it was just swapped around, the probability of B given A, then it would have been, the answer would have been probability of B. So just remember, well, or check the bottom of page 2 of my study notes. It is there as well. So let's just look at the last one, and then we can take questions on this. So So now they nearly say, but okay, we've done now with the questions that or the answers that we looked at. So assume now your probability of A and B is equal to 0.2. Then work out that probability. So we know the probability is going to be probability of A plus probability of B. So if we need to work out the OR minus the probability of A and B. So the probability of A, again, we know is 0.5. The probability of B is 0.3. And the probability of the AND, they now say to us, use 0.2. So in this instance, we're just checking, again, the normal probability theorem. So probability of the OR is that plus that minus that, which gives us the 0.6. Okay, so again, that one is correct. So we know which one is the incorrect one. Okay, let's stop here first and then get questions. If there is questions, but I think there will probably be a question or two. If no questions, we can move on. But are you guys happy so far? Does it make more sense than a week ago? Okay. Okay, cool. Yes, there's a question. Ian,
Yes, morning.
morning.
How do you know when you are using the formula when to multiply and when? Because it says A and B. So if they say mutually exclusive, if you say A and B, it's always 0. And when it's independent, then you have to multiply the two.
Yeah, so that is a given rule. So you don't need to know why it's like that. So mutually exclusive, the AND is always a 0. If it's independent, it is multiplication. Else they need to give you the AND, as in question 5 or in option 5. So if they don't tell you it's mutually exclusive or they don't tell you it's independent, then they need to give you the AND, what the answer for AND is. So I think that is the important one as well. They can't give you it straight like this without then telling you how to calculate the AND. Else you won't know. So they can't give you just the probability of the one and the probability of the other one and ask you questions around it without telling you how to get to the AND or to tell you this is the AND. Does that help you a bit? Cool. Okay, so it's and I think that is important. So it's nearly the AND will always be or mutually exclusive or independent, else it needs to be given to you. Otherwise, you can't do anything. Otherwise, it is basically there's information missing in the question. So that brings me to they love questions like that to include, to say what they could have done is they could have given you this as a question, and they could have, instead of writing something out in formula, they could have said, suppose that probability of A and B is that, and is mutually exclusive. Then they can give you in the options, and then normally the first option is you don't have enough information to calculate. And sometimes you then see, oh, but they only give me 2. And in the wording somewhere, it says it's mutually exclusive or independent. And sometimes they actually don't tell you, and they ask the same thing. And then you can say you don't have enough information. So just watch out. I'm just gonna make a note with that inclusive to see if I have one of those mutually exclusive or independent questions somewhere out of a previous exam. Just to see if there's something like that, because I think you guys have seen it now in assignment 1 as well, where you think you're doing the right thing, but then it's just a bit different, the question, or you've been working on nearly the same formula the whole time, and then they give you just a change in the formula. So I'll look for one of those questions where it nearly feels that they've given you all the information, but there's something lacking. Cool. So let's look at the next. I think there's 2 more questions on this, and then we can just stand still with this and go into study unit 5 as well. Okay, so now to that point here, they say, and okay, this is actually looking 2 events A and B that are independent. They give you, and I hate it when they do that, so I write it out automatically as decimals because I get confused when I need to work with fractions. Okay, so if they tell me it's independent, then I know there will be an and. Okay, so now they say 2 events of that. What is the value of, and here suddenly they ask, but no, I need the value of probability A and B. So you look at this and you can maybe say, but okay, I know if I look at that formula, it is probability A and B divided by probability of B. I have probability of B. I don't have probability of A and B if you're looking just for formulas, and then it would have been easy to say, oh, well, that's the incorrect one because I actually need it. But you have it because they tell you it's independent. So then we know the independent one is 0.25 times 0.75. And the reason why I'm writing this out is that you guys can also see, so divided by the probability of that. So those 2 actually cancels out. So we are sitting with that answer as the probability of A. And where is your probability of A? Okay, so it's that nearly is hooked onto my what I tried to explain in the previous one, that sometimes it looks like they don't give you the information, but in the words, it is there. Um, so that is nearly just because it's very easy to write this down, because also you will, with the pages that I give you, you will also get in that week before you write exams, uh, nearly a formula letter from the lecturer. I'll also share one with you guys with notes on, but you will get a formal formula page, and that is on the formula page as well. So it's very easy if you go through the formulas that you look at this and say, oof, I'm missing that, I don't have it. That is maybe the answer. So just be wary of that. Okay, let's go to the next one, and then we can take a few questions on study unit 4 again. Okay, so they like to give you all the data in a table that is already worked out, some of the probabilities, or they give it to you where you need to work out the probabilities. So when I get a table like this, I would nearly look at it and say, okay, here's a few things that we need to work out. And let's just check. We need to see which is incorrect. Okay, so when it is nearly, I scan the things, when I'm like events M and P are not mutually exclusive. Okay, so let's just go. Okay, so for M and P to be mutually exclusive, the AND must be equal to 0. So if this was mutually exclusive, that should have been that there is 0 people in that cell. Okay, so we know it's not mutually exclusive, but we need to get to the incorrect one. So then the next ones I will look at is just the simple probability of one of the variables. So probability of M is basically the total of M so the total of M divided by the total. Yes, I am recording, so no worries, and I'll also send the link just after the session. So the total 115 divided by 200 is 0.575. Okay, so unfortunately that is also correct. Okay, then I'm looking at, let's see if there's anything else that's easier to work out. So there's no ones that's a total, so it's or and then a given. Whoops, why did that happen? Okay, so which one to do first? So let's start with that one. So the probability of M given P is the probability of M and P divided by the probability of P. Okay, so let's check this out. So where is M and P? So again, this is again why I don't like that you guys are writing online, because you can't really do this. Because that is for me much easier than to say, okay, M and P, there is my 25 divided by probability of P. Probability of P is that one. And you can see 25 divided by 50 is going to be 0.5. What you could have, and you'll see I use the total numbers. So what and why I can do this. So that you could have also done by actually saying, okay, the probability of the M and P is actually 25 divided by 200. So that will give you the actual probability. And then the probability of only physics is 50, but also divided by 200. So because you're dividing the top by 200 and the bottom by 200, you can actually eliminate that. So that's why you will see I always nearly write only the numbers, because you always gonna have that you can cancel out the totals. So that's just again for me easier, so that I don't in the exam suddenly make a mistake because at the top I've written 200 and the bottom not, and then I get a totally different answer. So it's for me easier to work with the total numbers instead of dividing every time with 200. So that's just again merely a small tip from my side. Okay, so let's look at the probability of M and P. Okay, so probability M and P, so that is now the one that we have looked at, probability M and P, 25. So in this instance, there's nothing else that you can do than to say 25 divided by 200. They haven't asked us it for a given or with anything else, so it is only that probability that we want to find out. It is the same as in when we looked at the probability of male, we only wanted to find out what that probability is. So 25 divided by 200, 0.125, which then is that answer. Okay, so that is still correct, that is still correct, that's correct, this is correct, so we know actually which one is incorrect, but we're going to work that out now as well. Yes, there's a question.
I'm a bit confused as to when we actually use a different total. Like when do we use the 115 and when do we use the 200?
Okay, cool. That so when they ask you it as as a given, but now see what we've done here is using already the formula that you can. So let me quickly think, how can we do, I want to look at the example now out of this. Let me just quickly think about that, because it will be with a given. Okay, I'll think of an example for you. Let's quickly just make this finish, and then if I don't get one out of this, then I will look for or create another one. Because it's normally, where was that? It's normally more difficult in this instances, where you have a percentages, or where you have a probabilities already. So let's come back to this question to answer it for you. And maybe the answer would have been here, if these was already in percent or probabilities, then this would have been done differently. So let me go after this. I'll go back to that slide 4 or 5 and show there for you. I think that will make it easier to understand. If you get the raw data, it's actually hidden in the way that you do the processing. Because if you look at here, we set given P, so we used that total. But we needed to know what is the probability of P. So let me get back to that previous one and show it there for you. I think that will be, so if you use the raw data or the total numbers, then if you follow the process of the formulas, then you will actually just in that process actually have worked with it without really realizing that you've done it. So I'll show you in that previous one. Okay, so for the OR, we do the probability of C, so know where we've done that yet, plus the probability of F, know where we've done that, minus the probability of C and F, and know where we've worked that out as well. So probability of C, so let's just do that. So probability of C is 100 divided by 200, because that will be our probability. The probability of F is 85 divided by 200, sorry. Minus the probability of C and F, which is 40 divided by 200. And you can already see this is going to be a much bigger number than that. Okay, so I just quickly want to check Okay, so 100 divided by 200 plus 85 divided by 200 minus, so also what I normally do with this is say, we know everything is divided by 200, so I just say 100 plus 85 minus 40, which gives me 145, and 145 divided by 200. And typical one of those ones, 725. So if I just swap the numbers around, to even if you quickly look and you see the same decimals, but it's not the same number. Okay, so here we just looked at the probability of a one plus the other one, and then always the probability of the and that we need to subtract. Okay, before I go back quickly to the other one, are you guys much more comfortable with probabilities? If there's other questions, please ask. But I'll quickly go back to. Okay, awesome. Let's just go back to this one. Because here was, where was it? Is go question 5. At least it's recorded on our other session, all of the other things that we've written on here. Okay, question 5. The probability that a student achieves a grade A of marketing, grade A of marketing. Okay, so we know grade A of marketing is then 0.29, given that he or she does not achieve a grade of A in statistics. Okay, so what's the probability of an A in marketing given that she does not achieve a grade A in stats? Okay, so let's write this down as a formula. Probability that a student achieves a grade A in marketing. So let's just call that stats 1, stats 2, marketing M1, M2. Okay, so a probability that a student achieves a grade of A in marketing, given that he or she does not achieve a grade of A in stats, does not achieve a grade of A in stats, so given S2. Okay, so now we follow the same principle of a formula. So we know then that it is the probability of A and B. So the probability of M1 and S2 divided by the probability of S2. And now you will see where it comes in. So Let me just write M2 there again. Okay, so the probability of M1 and S2, M1 S2, divided by the probability of S2. See, so there we would have used the given. If so does that make a bit more sense? So I will now go back to the one that we just did as well, but is that a bit more clearer? So I
Yes,
think,
it is.
okay, so what, and I think that is what, so if I look at this one that we did with a given, so let's just write something down for you. So where's the M and P? So if that was probabilities, it would have been 25 divided by 200, which would have been 1,25. And that would have been 50 divided by 200, which would have been 0,25. So if we again did the formula, we would have said the probability of the AND, which is 1,25, divided by the total of physics, which is the 0,25. So if it was in probability terms nearly written already, you would have been automatically seen that we actually divide by that total and not that total. Okay, so that would have also given you the answer of 0.5. So I think it's just sometimes when I do my shortcuts, one that you can see is exactly the same as that. So yeah, so I hope that makes it clearer now. Okay, cool. So that was nearly the introduction to probabilities. Were any questions around this? I just now want to, this is a difficult one also to nearly put on Excel. I'm just thinking because there's so many possibilities of questions out of this, that it's one can put a table like this in, one can nearly make it that you do some basic questions around it. So I can look what I can actually add for you guys in a Excel to make it easier. But normally Excel for this is very difficult, because we never nearly know what we're gonna ask, but what we can do is set it up so that your easy questions will be covered by it. So I'll on the big deck of Excel, I will just add something for you guys. Okay, we've got about 10 minutes left in this session. So are you guys happy with study unit 4? Any other questions when we can use for 10 minutes for study unit 5? And just start off with that. Okay, so let's do that. I just want to see where is. Just let me know if you can see the new one that is on the screen. Okay, cool. Okay, so let's just start with this. So you will, in your exam, again, study unit 4 that we just did, you will probably get 1 or 2 questions. It will be much more now in your assignment, but in the exam, it's about 1 or 2 questions. Then in your exam, this study unit is normally the one that there's more, because what we are doing in study unit 5 is there's 3 things that we look here at. So we look at the discrete distribution, then we look at the Poisson binomial, and then the Poisson. So normally in your exam there will be 3 questions on study unit 5, and there will be 1 on each of these. So if you work it out, normally you will have about 2 questions per study unit. Session 1 is normally 12 or 13 questions. Session 2 is when we'll rest. So that it makes up 25 questions in your exam. So study unit 5, about 3 questions. So what I have included for you is also here, and I'll do my normal summary pages as well over the weekend, but it is to say, because they like again to ask definitions, so how to work out the mean, then how to work out the variance and the standard deviation around that variance. This next week I will show you how we use this in Excel, because for certain things it's easy, but when you start working out the variance, it really becomes a long process, specifically in your discrete probability. It just becomes a nuisance, and it consumes a lot of time. So I will show you that. So discrete, remember the formula is there for the mean, formula is there for the variance. One of the things we've know about all the probabilities is that the sum of it should be equal to 1. So it doesn't matter if it's discrete, Poisson, binomial, normal distribution. When we get there, all probabilities always are between 0 and 1. We will go into binomial, and you will see in your study guide and in the textbook that there's a lot of focus on the formula. I want to show you next week, because I think we won't get there, how to use the tables, so that let me think about that question about the percentage. Not really. So yes, it is, because it translates into percentage, but other things can translate into percentage that is equal to 0 as well, or negative. So the reason why, and the easiest to explain it, is with a why everything adds to 1 is with a normal distribution. And the normal distribution, normal curve, so everything underneath this curve, the probability is always equal to 1. So now you get, say, a different distribution that looks something like that. Always underneath a curve, it adds to 1. So we always translate it into percentage, but not really because it's percentage that it's always positive. It's just more how the rules for probability are set up. Because we'll see later on in study units 6 and 7, where we work with Z values and things like that, where you can get negative values, but it's always a positive probability. But that's for later. We're not going to get there yet. Binomial distribution, it's a bit easier to work out your mean and your variance. So there it is much more straightforward to work out your mean and variance. See, and they normally give you all of that, so you can actually just make a calculation. Then when we get to Poisson, again, they give you a formula that you can work out all the probabilities. I'm going to show you again how to use the formula page, because if we sit with a number of, say, a sample of 20, you don't want to make 20 calculations. Yes, there's hand.
I'm sorry. I just want to ask, in the exam, will we be given the formulas? Because I am already confused.
So I think what is nice about your exam at least is they give you a formula page in a week before. You can use all of this that I'm showing, you can use. So that's why I will send all of this as PDFs. You can use it's open book. So please don't study these formulas at all, because no, there was a stage where they gave the formulas that you needed to use it, but we passed that stage of ludicrousy. We don't need, yeah. So please don't, because what I would do if I was you, but I'll do it in any case for you, is so when you go through this study unit, I would just write, okay, I'm busy with discrete as these formulas. I'm busy with binomial as these formulas. I'm busy with Poisson as these formulas. But please don't try to, even in the assignment and in the exam, stay away from using the formula nearly. So that's why I want to show you in detail how to use the tables. Or we use, and that's what we've done in the past as well. You can actually use, if you have another device, an online calculator. Even if this is one of those apps that looks at what you're doing and things like that. Stats is an open book exam. So the only thing that you just can't do is speak to somebody or be on any of the groups and ask questions. but you can use any other assistance, all notes that you have. If there's online calculators that you can use, so I think that's why it's also much easier if you want to use a calculator. You can download a calculator instead of buying a calculator, because those tools are available. Just the last thing on Poisson, and that we will also go in a bit of more detail next week, but a place where they nearly always try to catch you out is here the variance and the mean is exactly the same. So just remember, in Poisson, the mean and the variance is exactly the same. Where all other places it's not. So discrete, you've got your mean, you work out your variance. Binomial, you can see you work out your mean, you work out your variance. So very important in Poisson, they're going to give us a thing called lambda, and that lambda is equal to your mean, and that lambda is equal to your variance. So what they do often is that they give that in a definition, or what they do is, instead of variance, they say lambda is equal to the mean is equal to the standard deviation, which is very close but not. So definitely that will come into a play, but we'll look at it next week. So do I need a second device? I would say yes. Second screen, perfect, because I'm using at the moment a second screen. So second screen is perfect if you can. So my nearly advice on this is always, it's very difficult to, and I know it, not everybody has access to all of these things, which makes it bit unfair. But for you, if you can write on a laptop or any computer, but not on a cell phone, it's very difficult to write your stats exam on a cell phone. It's just, yeah. So if you can write it on a laptop or a computer or anything like that, that will be first price, and then you have your cell phone as a second device for certain things. Second screen, perfect, because then you nearly have your Excel spreadsheet on it. You can work with that. So even if you have the luxury of somebody else in the family that also have a laptop, and you can use that as your second screen nearly for Excel, perfect. So I would really recommend that somehow. Even I don't even know if they allow you to write in one of the UNISA facilities, so it's probably not possible. But the nearly the more things you have access to for the stats exam, the better. Okay, so that's the end of our session today. So we'll go into much more detail around the discrete, Poisson, and binomial in next week. That is if we don't get any feedback yet on assignment 1. Otherwise, I want to I want actually to start and go through assignment 1. But if we don't have feedback yet, we'll finish off study unit 5, and at least we've done study unit 4 and 5 for your next assignment. See, and I think that is nearly that's very cool. So that's why nearly, even if you, and I know it's sometimes not the ideal place, but if there's even a coffee shop that have free, or not free Wi-Fi, but have Wi-Fi, and you can sit there with something. But if there's like this computer center in Centurion, interesting name. We won't say what what that place is in Cape Town, but yeah. So, but if you can get to a place like that, it's perfect. I know some of the libraries used to do it as well, but I don't know if those things are still available. But if you can get to a place where you actually have access to a computer and things like that, it will be perfect. Okay, so that's it for today. Um, we will continue next week with this, and we'll finish study unit 5 next week. So we way in front of when your next assignment is due. So we'll probably then finish study unit 5 next week. A week after, we can do a recap of your first assignment, and then the week after that, we can probably still fit in a recap session on study unit 4 and 5, and be in time for you to still complete your second assignment for second time or something like that. Okay, have a good weekend, everyone, and see you next Saturday again. Unless there's any questions.
Thank you. I hope next week we get the feedback for the assignment, because standard deviation, it was a stressful call for me.
Agreed. No, so I'm also, I have asked the lecturer. So he said that you guys will get, I don't know if you have received any feedback yet, formal feedback. So I think there
Not
was,
as yet.
okay. Yeah, so he said that he is busy with a formal feedback. So, and then on that, he will send the tutors also the basic formal feedback, and then we can work from there. So I'm also hoping that it's actually next week, but let's see. Let's take it from how it goes. Okay, great, everyone. Have